an ice and dust fossil between 3 and 11 billion years old, hurtling through our space at 68 kilometers per second, a speed so extreme it laughs at our cosmic speed limits. This is 3I Atlas, the third interstellar visitor we've ever confirmed. And it's not just passing through, it's rewriting the laws of comet physics, shattering every definition of what a comet should be. It has a forward-pointing tail, a surface unlike anything we've ever measured, and it has forced the world's most powerful telescopes, Hubble and James Webb, to scramble for time. As we speak, this enigmatic traveler is diving toward the sun on a trajectory that will either reveal the deepest secrets of its alien birth or tear it to pieces. The anomaly has arrived, and the data it's sending back suggests we may be looking at the single most unique object to cross our path in recorded history. 3I Atlas discovery began not with a sophisticated space probe, but with a humble, ground-based project dedicated to saving life on Earth. In early July 2025, the Asteroid Terrestrial Impact Last Alert System, ATLAS, a NASA-funded survey operating out of Rio, Chile, made the crucial first identification. The team tagged the object, and after initial trajectory analysis, the 3I designation was confirmed, marking it as the third interstellar object to grace our skies, following the enigmatic Oumuamua in 2017 and comet Borisov in 2019. Atlas was immediately distinct. Its trajectory was a hyperbola so pronounced that it left no doubt. It was not bound to our sun, it was a tourist, accelerating through our system before being flung back into the interstellar void. And what acceleration! Initial measurements placed its inbound velocity at a blistering 58 kilometers per second. To put that into perspective, the escape velocity from Earth is about 11 kilometers per second. Atlas was moving over 5 times faster than what's required to break free of our planet's gravitational grip. It was a cosmic bullet shot into our system. By its closest approach to the Sun, a crucial event we'll discuss shortly, its speed will peak at a stunning 68 kilometers per second. This incredible speed tells us two things. First, that it originated from a completely different stellar nursery, and second, that its journey has been epic in scale. It has been estimated that Atlas has been traveling through the galaxy for anywhere from 3 to 11 billion years. Think of that. This object contains ice and dust that was formed before our sun was a main sequence star, before our planets coalesced a true fossil of the galactic past. If its speed wasn't enough to capture the world's attention, its size created the first major controversy. Early estimates before high-powered telescopes could penetrate the haze around its core suggested a massive size, perhaps up to 10 kilometers in diameter. This number led to immediate alarm among some astrophysicists. Dr. Avi Loeb, the controversial Harvard astrophysicist, famously argued that an object this large should be an extremely rare occurrence, given our current understanding of material density in interstellar space. This observation formed the backbone of his now famous and heavily debated suggestion that Atlas might not be a natural object at all, but rather a piece of alien technology, a theory we will scrutinize later. On July 21, 2025, the Hubble Space Telescope, the world's most famous orbital eye, captured this stunning image. At a distance of 446 million kilometers from Earth, Hubble's observations allowed scientists to refine the size estimate of its solid nucleus. The results were dramatic. Atlas was smaller than initially feared, with a nucleus diameter measured between a lower bound of 440 meters and an upper bound of 5.6 kilometers. This massive reduction in the size estimate was a direct result of a second, crucial anomaly. Atlas is incredibly, ferociously active. When comets approach the Sun, solar radiation causes their volatile ices to turn directly into gas, a process called sublimation. This gas and dust forms a cloud around the nucleus called a coma, and a spectacular tail. Most comets in our solar system become active when they are around 3 to 4 astronomical units from the Sun, where 1 AU is the Earth to Sun distance. Atlas, however, started showing intense activity much further out. Data from NASA's Transiting Exoplanet Survey satellite revealed observational data dating all the way back to May 2025. Analyzing this data, scientists made a shocking discovery. The object's flux, or the amount of energy received from it, increased by a factor of 5, not the expected 1.5 increase due to distance alone. This profound surge in brightness suggested that Atlas was active when it was still a whopping 6 AU away from the Sun, near the outer limits of the main asteroid belt. This level of hypervolatility suggests the comet's composition must be exotic. What was it releasing so far from the Sun? It couldn't just be water ice. It pointed to the presence of extremely volatile substances like frozen nitrogen or hydrogen, which sublime at much colder temperatures. The nucleus of Atlas is, in essence, a super-pressurized geyser. Further compounding this mystery were the findings from the James Webb Space Telescope on August 6, 2025. Using its near-infrared spectrograph, James Webb probed the chemical composition of the coma. They found a complex coma morphology, suggesting a range of different outgassing patterns. Crucially, the data suggested that at that stage, carbon monoxide and carbon dioxide were sublimating more than water. This led to yet another bizarre sight. A surprising amount of dust was emanating from the comet in the direction of the Sun, a tail that points forward, caused by fragmenting dust grains reflecting more light. It's an action-reaction phenomenon, where excessive gas production is launching dust grains away from the core and into the sunward path. The spectroscopic and polarimetric analyses of 3I Atlas provided the most compelling evidence that this object is fundamentally different from anything born in our solar system. It's a cosmic fingerprint that doesn't match any known file. Observations from the Gemini South Telescope in Chile in late August 2025 were critical. They captured not only the coma, but also a measurable tail, spanning about 1 to 1/20th of a degree in the sky, a sign of its increasing activity as it drew closer to the Sun. More importantly, the spectrograph confirmed an emission feature in the cyanogen band, proving that Atlas was releasing cyanide molecules. This is a normal process, but the rate and context were not. A paper published in September inferred that the comet was releasing around 800 sextillion cyanide molecules per second. While this is a high number, it's actually on the lower end of the scale for many comets in our own system. By measuring the ratio of dicarbon to cyanide in the coma, scientists were able to classify Atlas as one of the most carbon chain depleted comets ever observed. This means its coma lacks longer chain carbon molecules, like dicarbon and tricarbon. The data showed that Atlas produces less than 0.09 dicarbon molecules for every cyanide molecule. Why is this significant? The chemical composition of a comet's core is thought to reflect the conditions in which it was first formed. The fact that Atlas is so depleted suggests it formed in an entirely different, perhaps much colder or radically different, region of space compared to our own Oort cloud objects. Interestingly, the previous interstellar visitor, Borisov, also showed this feature, hinting that this might be a common trait of interstellar comets, though our sample size is still tiny. But the most truly unique characteristic emerged from studies of light polarization. In early September, the first ever polarimetric observations of Atlas were published, only the second such study for an interstellar object after Borisov. Polarimetry measures how light scatters when it hits the dust and gas in the coma, revealing physical properties like the size of the dust grains and the structure of the surface. The finding was unprecedented. Atlas exhibited an exceptionally deep and narrow negative polarization branch. Light polarization is measured relative to the scattering plane, the line from the observer to the comet to the Sun. Positive polarization means the light is scattered perpendicular to this plane. Negative means it's scattered parallel. The extreme depth and narrowness of Atlas's negative polarization signature means it is scattering light in a way that has never been seen before for any other known comet or asteroid in our solar system. Even Borisov showed a positive polarization. This distinct behavior suggests Atlas belongs to a class of small planetary bodies that we know absolutely nothing about, a category reserved for trans-Neptunian objects or centaurs. Yet it is utterly unique among them. The sheer number of anomalies surrounding 3I Atlas, the extreme speed, the sunward tail, the unusual composition, and the one-of-a-kind polarization inevitably led to a resurgence of the most fascinating and contentious theory in modern astronomy. Could it be alien technology? The primary advocate for this theory is Dr. A.V. Loeb. His argument is multifaceted, but centers on the improbability of the object's initial size estimate and the complexity of its motion. In his view, the non-gravitational acceleration, the push, caused by outgassing, could be interpreted as engineered maneuvers. For many, this idea turns the object into a Rorschach test in space, where scientists see what they are predisposed to find. However, the majority of the astronomical community has pushed back, firmly grounding their rebuttals in the latest data. The central pillar of Loeb's argument, the 10-kilometer size estimate, was based on outdated pre-coma penetration measurements. As the Hubble data confirmed, the nucleus is significantly smaller, between 440 meters and 5.6 kilometers, making it statistically less improbable as a natural object. Furthermore, the complex motions and trajectory data for Atlas have been overwhelmingly shown to be best explained by natural dynamics. The object is volatile, highly active, and is simply undergoing physics that we observe in our own comets, but on an exotic scale due to its alien composition. The extreme negative polarization and the carbon chain depletion are not evidence of engineering. They are evidence of a different formation environment. They are geology, not technology. The consensus remains that while the mystery is profound, the most parsimonious explanation, the one requiring the fewest extraordinary assumptions, is that Atlas is a natural, albeit extremely unusual, interstellar comet whose composition differs wildly from the material that formed our own solar system. The most crucial, and perhaps the most dramatic, part of the 3I Atlas story is happening right now, as it closes in on the Sun. As of mid-October 2025, Atlas has hurtled past the orbit of Mars and is deep within the inner solar system. We are now heading into a period of maximum suspense and maximum blindness. The first critical moment occurred on October 21, 2025, when Atlas reached superior conjunction. This is the moment it passed almost directly behind the Sun as viewed from Earth. The Sun's overwhelming glare, a radiation curtain tens of billions of times brighter than the comet, has rendered us completely blind to Atlas. This blindness sets the stage for the true climax, the perihelion. On October 29th or 30th, 2025, 3I Atlas will reach its closest point to the Sun, approximately 1.36 to 1.4 astronomical units away, a distance just beyond Earth's orbit. This is the moment of maximum thermal and kinetic stress. It will be moving at its peak velocity of 68 km per second, and the full force of the Sun's heat and plasma will be focused on its ancient, icy core. This period is not just a high point in its journey, it is a moment of extreme risk. As veteran comet expert Dr. Karen Meach has stated, comets are very fragile, dirty snowballs that often break apart. The rapid outgassing and the intense thermal shock of the perihelion could cause Atlas's nucleus to fragment. If it does, we would see a renewed and dramatic bout of emissions as fresh, untouched water ice is exposed to the Sun's radiation for the first time in its billion-year history. This would create a flare-up and potentially a visible spectacle that would dramatically change its light curve. For weeks, we are left in the dark, wondering what is happening to the interstellar visitor. Will it fragment? Will the extreme negative polarization change? Will the carbon-depleted nucleus somehow begin to fluoresce green, as some observers have hinted at, indicating a dramatic rise in dicarbon production? Our next opportunity to observe Atlas will not be until late November or early December, when it has moved far enough away from the Sun's glare. Astronomers around the globe are already planning the next phase of observation, using powerful assets like the Hubble, James Webb, the Gemini Observatory, and dedicated solar missions like SOHO, Solar and Heliospheric Observatory, and MAVEN Mars Atmosphere and Volatile Evolution. When Atlas re-emerges, the race to gather data will resume, driven by the knowledge that this may be the last time we ever see an object from its star system. To recap, what we know of 3I Atlas is far more than a simple astronomical observation. It is a profound learning opportunity. In its high-speed passage, the object has gifted us with unique data points: its extreme velocity, peaking at 68 kilometers per second, its unique composition, showing it is profoundly carbon chain depleted, its exotic surface properties, demonstrated by an exceptionally deep negative polarization, a fingerprint not matched by any other object, its hypervolatility, becoming active at 6 AU, likely releasing nitrogen or hydrogen ices. Atlas has confirmed that the interstellar medium is not just a void, it is a dynamic, complex environment, carrying diverse materials between star systems. Each subsequent interstellar object, from the dense, rocky Oumuamua to the familiar but foreign Borisov, to the hypervolatile and unique Atlas, provides a new piece of the cosmic jigsaw puzzle. This is a messenger from the galactic past, and one 1 billion-year-old traveler that has briefly illuminated our path. By studying its wake, we are not just solving a mystery, we are learning about the formation of other solar systems, the chemistry of alien worlds, and the true diversity of the universe. When 3I Atlas eventually vanishes into the blackness of space, it will leave behind a set of questions that will drive astronomical research for decades. How long has it been traveling? Can we trace its elusive origin? And what secrets about the universe's earliest material does its fragmenting tale hold? Thanks for watching. Stay around and listen for more update on 3I Atlas. If you have any questions, let me know down below.